All right, welcome to Math Class Rebate here, and we are going to be talking about logarithms. And remember the sacred chant: logarithms are exponents. That's the only thing you really need to get out of this. Logarithms are exponents. So in looking through this pattern in both classes, we got to this idea that 2 to the first power equals this entry, 2. 2 to the second power equals 4. 2 to the third power equals 8, and 2 to the fourth power equals 16. And that we can actually fill in all these blanks along the way by raising 2 to some power to make it equal any number. And eventually we'll learn how to get the calculator to do some of that. But right now we can just do a little guess and checking by going to the calculator, and I enter in 2 to the x into my magic equation box there. And then I can go to my table, and you can see that as 2 increases, right, I get really close to 6 at 2.6 something something. Okay, so that's one idea, and I can make it equal any number if I carry it out to enough decimal places. But let's go back to this. Okay. So the equation that you could fill in is y equals 2 to the x. And I can test that in my calculator, and I encourage you to do that at this point. But as you were filling this in, when you were filling in the missing entries of the table, you were probably saying to yourself something like, what power of 2 is 8? And the answer was 3. So the values in the first row are the exponents, or powers, of the base of 2 that produce the values in the second row. This is such an important and widely used mathematical concept that it is given the special name logarithm. And logarithm simply means exponent. Okay? The logarithm is perhaps the single most useful arithmetic concept in all of sciences, and an understanding of them is essential to understanding many scientific ideas. No matter how much you can be challenged by logarithms, just remember, logarithms are exponents. So, here's a logarithm. So when you were talking about logs, we use this thing as just the log. This is the base, and this is called the argument. And that's what it equals, okay? And what it's saying is, what power of 10 is 100? Well, we know that if I raise 10 to the second power, that equals 100. Okay, so the power would be 2. What power of 2 is 32? Well, I would raise 2 to the fifth power to make it equal 32. In fact, we can rewrite it that way. We could say this would be power form. Sorry, losing it there. 2 to the fifth power equals 32. This would be power form. Okay. Let's move down just a little bit. Here's a logarithmic that says the same thing. Log base 2 of 32 equals 5. So we say this is the exponent. This is the argument. And this is the base. Let's try this one. What does this mean? Log base 5 of 25 equals 2. This means what power of 5 is 25? And the answer is 2. In other words, I have to raise 5 to the second power to equal 25. A logarithm is just an exponent. And it need not be a whole number. Fill in the blank below. Okay, so let's check it out. So 10 to the first power is 10. 10 to the 1.76. We put that in our calculators and say 10 to the 1.76 equals 57. Okay, 0.5. And you can see that sort of makes sense because 10 to the second is 100, right? So 10 raised to a power somewhere in between those is going to be some number somewhere in between those. Here's a logarithmic statement saying the same thing. Okay? 10 log base 10 of 57 equals 1.76. The power of 10, what power of 10 is 57, and which is approximately 1.76. Okay. 10 is a common base for logarithms. If you're given something that doesn't specify the base, then it'll just say log. But you can have log base anything. So 10 is the common base. Log of x is called the common log. And it is shorthand for writing log base 10 of x. You just leave out the 10. It's just assume that if there's nothing there, right, then really it's log base 10. Log of x is the exponent you put 10 to get x. So let's check our understanding. And so I want you to take a minute and go through all these problems and see if you can figure out what each one is. And remember that this is all of these that don't say anything are log base 10. So what this is asking, for example, is what do I have to raise 10 to make it equal 100? Well, that would be 2. So I want you to take a moment to fill in this chart, and then you can start the next video.